measurement of time, we'll call it a second. They're interchangeable, but we'll just say that's what it is. Okay, so just say that you have a stream of photons hitting you. All right, just how many times they activate, within the the range of your frequency. Now you understand why you have a frequency range of vision. You have a fundamental frequency of existence, and then your nerves can react to a certain amount of if the number of photons hitting your eye per second exceeds the amount that your rods and cones can react to. Think of a speed bag where you hit in boxing is do 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 do. If you start hitting it too fast, it doesn't have any rebound. It's just going to stay there. And because your sensory perception is on, off, or frequency, and how many times that happens per second, if it just is too fast or too slow, too, few times per second, you're not going to perceive anything based upon your core vibrational state. Okay, then. So if you know that another level up from atoms, there are parts and components of the sun that are there and not there, and there and not there. Well, what would happen is this. You see, when light is emitted from that reaction, it is slowed down right away through a certain amount of resistance of the dark energy. So light is emitted at a certain speed. Just imagine spitting, okay? Slow it down in your mind, like that, okay? You get a stream of photons going. That's because you have individual photons because of the frequency of emittance of them. But then the very existence based upon that is there and not also. So what's really going to be occurring is a stream of photons and resistance, slowing them down slightly. And then another one, because then the sun, think of it real basically, say the sun disappears. So now there is no emittance of light. But then it comes back and emits it again. So now there's a gap in between, except the new emittance is at original speed, which will be faster than the first emittance. And this is a very basic way to look at it. It's more complex than that, but not much more complex than this. But I want to keep it simple. So like a cue ball in a pool game, you're colliding the photons. And so picture in your mind this new stream coming faster, and then the photons and the lead photons collide with the rear photons in the first emittance. And what happens? Like pool balls in billiards, they collide off of each other, and one goes back or is slowed down. It depends on your point of view. And the other is pushed forward. And it just keeps doing that based upon its refreshment, the refreshing of its existence in different scales. So then my question of, then polarized glasses. I said, sure. The ones that collide outside that plane don't make it through. They get cut off a little bit. Not completely. They'll make it through the other lines, but it will be not in a frequency you can detect because it alters its stream. So imagine a 360 plane where they have potential of colliding in this plane, that plane, that plane, and the polarized glasses choose what plane it would exist in. So I said, well, okay, then what are colors then? I looked at the lawn. It was green. I said, well, what's occurring then? And it corrected a few things for me. Okay, you look at that green lawn, that green leaf. You think it's absorbing all of the light except green. I said, yeah, that's what we're told in science. I didn't say it, that's what we're told. No, that's not what's occurring at all. appears that way, but that's not what it is. And I won't get too complex here, but when the light hits the leaf in the female energy, or any color, let's say, and it interacts with the energy of it, and it's absorbed and then emitted, well, same deal of emittance, but what you're looking at is the frequency of existence of whatever the color is. So the reason the leaf is green is not because it's absorbing everything but green. No, it is reflecting all of the light, but it's reflecting it based upon its frequency of existence. And it started to make sense to me. So it's, say you have a giant tennis racket, and you spurt a constant amount of balls. Like, say the tennis racket has a 30-foot diameter. Okay, that's how big the head of the racket is, and you have every given second you've got 1,000 balls coming at it, and it's a constant stream of these balls, say, so they're just constantly coming. But the racket has to go back and then forth and back and forth, and as the balls are hitting the racket, when it's moving back, they're not going to be rebounded the same way as they are as the racket is moving forward to the constant stream. You can sit in the swimming pool and the water's just there, and you can make a splash, but the splash is dependent upon your hand moving forward and hitting the water. Same thing with light. Same thing with reflection of light. It's the existence. It's there to reflect it, and then it's not. And then it's there, and then it's not. So the question then that occurred in my mind, well, why would a darker color get warmer in the sun than a lighter color? What occurred in my mind through this interaction was the idea that, okay, well, remember, you are in a bandwidth of existence. Every color that you perceive is a vibration that you are perceiving. If it can reflect light, or more specifically, be seen by you, it's in your bandwidth and therefore in the bandwidth of interaction of light. But there's other wavelengths of light energy or electromagnetic energy that could heat something up. Of course, you already know that. If a part of what it's heating up is within the bandwidth of excitability or able to make an interference pattern reaction. You just have to really slow it down in your mind and say a black color in the sun, its vibration is slower sometimes. Why do I say sometimes? Because, see, what you perceive as black, once you get below the frequency of excitability to your rods and cones, anything slower than that will be perceived as black to you, but it doesn't mean it's at the same frequency. There can be many things perceived as exactly black. All that means is it's no longer stimulating your eyes. White would be the most intense stimulation. But what if something was vibrating so fast that it could not be perceived by your eyes? It'd be black again. Or, in that case, transparent. But you've got to understand, when you look at the sky at night and you see the stars, sure, but what about everything in between the stars? You perceive it as black, right? But it's not black. It's not absorbing light or emitting the color black. It's just lack of stimulation. That's why you perceive it as black. If it's vibrating slower, though, in this realm, if you have something that's at a slow vibration and that's why it's black or very dark, it's like hot potato. Okay, I'm going to hand you a potato and it's burning, okay, and you want to get rid of it as soon as possible.